Our homework last night was page 63, number 2 to 6. We're going to go over questions number 5 and 6 right now. Number 5 says that a rock takes 1.575 seconds to drop 2 meters down toward the surface of the moon. What's the acceleration due to gravity on the moon? Bit of a different question here, because we're dealing with one of those free fall questions now, and we said every time an object free falls under the influence of gravity, and just gravity, then it would accelerate downward at negative 9.81 meters per second squared, right? Well, guess what? I lied. It doesn't accelerate downward at 9.81 meters per second squared here. How come? We're not on Earth. Okay, we're not on Earth. Like 99% of the questions we get will be on Earth, and G will be negative 9.81. But it's not negative 9.81 on the moon. We've got to find it here for the moon. So let's write down some givens here. We know this is a group B problem, right? Because it's acceleration. We know that in number 5, it takes the rock 1.575 seconds to fall. What is this 2-meter thing? What are we going to call that? We're going to call that velocity, displacement, acceleration. What is that? That's displacement. I'm missing something, though. What is it? Yeah, we're going to make that negative 2 meters, because the rock falls 2 meters. It ends up 2 meters below where it started. We want to find A, the acceleration due to gravity here. Is there anything else that I have in question number 5 if I read between the lines here, Ben? VI. Yeah, what is it? 0. Good. VI is 0 meters per second. If I drop it, then it means it's not moving initially. It is very shortly thereafter, but at the beginning of the problem, we'd say the velocity is 0. All right, we got T, we got D, we got VI, looking for A. Which equation of our group B equations do we want to use to solve for acceleration here? Anyone? Okay, if you're not sure right now, haul out your equation sheet, because I'm going to pick on somebody in just a second here, and you're going to give me one here. Which one, Rachel, which one are you going to use here?
I use D equals VI
Yep, that's probably the one that I would use as well. But even if it wasn't, that's okay, right? We've said it a million times by now. If you use an equation from the right group, you're not going to get the wrong answer. The worst case scenario is you end up with no answer. You're not going to get the wrong answer. So D is equal to VIT plus 1/2 AT squared. Solving for A here. Got to get rid of what's not attached. What is not attached to the A? VIT. So we're going to take that over by subtracting, because it's added to the 1/2 AT squared. Okay, we're still not there yet, but we're getting there. What is attached to the A? What is attached to the A, the acceleration, William?
1/2 T squared.
Right, and how do I get rid of that? Yeah, it's multiplied by A, 1/2 T squared, so I'm going to take it over by dividing. I can take it over 1 by 1 if I want, but it makes sense just take it over all together, right? So we're going to say D minus VIT over 1/2 A equals, over 1/2 T squared, isn't it? Equals A. Now we sub our numbers in. Now, even if you get this far with the algebra, with the rearranging of it, some of us still have trouble plugging this into a calculator. Okay? Follow my advice on this, and I'll show you what that advice is in a second here. We're going to say D is negative 2.0, subtract VI. Oh, this is just 0, isn't it? So just negative 2 on the top. Negative 2.0 minus 0 over 1/2 of T squared. Unless, I've said this before, unless you're really, really, really good with brackets on your calculator, and if you think you're really, really good with brackets on your calculator, you're probably wrong. You're probably not really good with brackets. You might be, but probably not. If you're not really, really good with brackets, then we should all try the same thing first. How should we solve this in the absence of being experts at using brackets. Do the bottom first. Okay, let's say on the bottom, let's say 0.5 times 1.575 squared. Don't try to do anything with the top, just what's on the bottom. So there's my number for the bottom, 1.2403. So I've got negative 2 over, what did I say that was? 1.2403. Well, now it's easy, right? Now I'm just going to say negative 2 divided by 1.2403. You guys know the shortcut there? I could just type in 1.2403, right? Or I could type in second function answer and say negative 2 divided by 1.2403 gives me negative 1.61. And should be 3 digits, right? 4 digits here, 3 digits here. Final answer is the least precise, which is 3 digits. So 1.61, negative 1.61 is our answer. It's about 1/6 of what it is on the Earth. Anybody know why gravity is so much less on the moon than it is on Earth? You might be thinking the right thing. You're not saying it right, though. It doesn't. Yes, it has less mass. It has a lot less mass. It's about 1/100th the mass of the Earth. How many people got negative 1.61 there? Good. Good. 6. At the beginning of a game, a referee throws a basketball vertically upward with an initial speed of 5 meters per second. That's the maximum height above the floor reached by the basketball if it starts from a height of 1.5. Good question. Good question. I'll tell you what. I'm going to, for the time being, just pretend it started at the ground. Okay, just forget about that initial height. It started on the ground. This is a group B problem because the ball slows down as it goes up. We'll say that VI, for number 6, is positive 5.0 meters per second. We're going to say that A is negative 9.81 because it slows down as it rises up at that rate. We're going to find the displacement when it reaches the max height. What else do we have? There is something. Final velocity is what? Yeah. If we're analyzing just the trip up, then VF is 0 meters per second. So I think I'm going to do VF squared here. Solve for delta D. Get rid of what is, Parker, what do you get rid of first? What's not attached, good. So what's not attached to this? Good. So let's take the VI over by subtracting. VF squared minus VI squared equals 2AD. Now get rid of what? Dylan, get rid of what? Get rid of what is attached, right? What is attached to the delta D? Yep, 2 times A, good. So we're going to say VF squared minus VI squared over 2 times A is equal to delta D. VF is 0. 0 squared minus 5 squared over 2 times neg 9.81. Are you going to solve for first here? Solve for the bottom. Yeah, solve for the bottom. 2 times neg 9.81, neg 19.62. And then let's write that down. What's 5 squared? Oh, you know this, right? 5 squared is 25. Negative 5 squared is negative 25. You're not squaring the negative there, right? You're just squaring the number, not the negative sign. Right? Does that make sense? It's VF squared minus VI squared. So it's like saying this, right? Square the VI, don't square the negative VI. So it's still negative 25 divided by negative 19.62 gives me 1.27 meters. But that's not my answer. This is how high it goes above where it started. If I want to know how high it goes above the floor, what do I got to do? Add what? Because it started 1.5 meters above the floor, right? So if it went 1.27 up from where it started, I have to add the 1.5 meters that it started above the floor. My final answer is going to be 2.77 or 2.8 meters. How many people got 1.27 or 1.3 for that? Okay. And how many people took it the next step and said 2.8 because they added? Good. Good. Like if this is a question on a test, like if you got 1.3, you get good marks for that. Like if this is a question out of 4, you'd probably get 3 out of 4 for that. But to get 4 out of 4, you got to recognize that next step. All right? We're not going to spend the rest of the class working on problems at all because I think we're getting this stuff, this acceleration. We've been working on acceleration for a number of days now, but I will give you a little bit more time in class here to work on a few more questions. Let's go from let's just start working at question 7, and I'll give you a little bit more time. We'll see how it goes, and then I'll make a judgment as to where we stop there. And then in a bit, maybe about 20 minutes or so, we'll move on to our next topic. Okay, let's have a quick look at question number 9 and 10. Now, number 9 says, if a baseball player popped straight up into the air, baseball player, yeah, probably the baseball player's not going up, staying in the air that would be impressive if the baseball player stayed in the air for 6.25 seconds. That would be very impressive. Determine the distance from the point of contact with the baseball's maximum height. So, remember that in these up and down questions, you've got a couple. In fact, you've got 3 options for each of them. And sometimes all 3 options will work for you. Sometimes only one of the options, or sometimes 2 of the options will work for you. The 3 options are these. This would be for question 9, question 10, any of them where something's going up and coming down. You can analyze the trip up and down, or you can analyze just the trip up, or you can analyze just the trip down. If you're analyzing the whole thing, let's make this option A, option B, and option C. If you're analyzing the whole thing where you're going up and down, then VI is something, and VF is something. Okay, you'd have to either be given those values, or you'd have to solve for them. But it's not, neither one of them are 0, right? I mean, think about this. If you throw a ball up into the air, VI is not 0 because it wouldn't go anywhere if VI was 0. Now, if you're looking at the second problem where you're just analyzing half the trip up, then you would say here, VI is something, but VF would be 0 if you're analyzing just the trip up. Now, if you're analyzing just the trip down, then you would say, well, VF is something now, some value, we don't know what it is. Or maybe you do know what it is, but it would have to be given to you, or you'd have to solve for it. What would VI be in this case if you're analyzing the trip down? 0 meters per second. Now, we should say that we have a certain amount of time that it takes to go up and down if we're analyzing the whole thing. In question B, my time would be half of that. The trip up would be half of the time, and the trip down would also be half of the time. Does that make some sense? Now, which one is better to use? It depends. It depends on the question. Okay, let's look at number 9. What do you think for number 9 here? We've got a baseball being popped straight up into the air, has a hang time. This is the total time, 6.25 seconds of time to go up and down. So we've got this time right here. Now, that doesn't mean that that's what we're going to do. It doesn't mean we're going to analyze the whole trip, but that's the time we have. What's the distance, the point of contact to the maximum height? We want to find out this maximum height. What do you want to do? The whole trip or half the trip? I think half the trip, right? Up or down? Doesn't really matter. I don't think it really matters there, right? Let's pick, what do you want to do, up or down? Up, okay? Trip up. So for question number 9, I'm going to go green here because we're analyzing the trip up, and that's what I drew this one in as green. We're going to say, for this one, my time is 3.125 seconds. Why did I do that, 3.125 seconds? Well, the whole time was 6.25, Jared, so I got to divide it by 2, right? The time for the trip up is half of that, or the time for the trip down would be half of that as well. We know that A, I should have wrote this down over here for all 3 cases. A would be negative 9.81 for all 3 of those cases. What else do we have there in the green one if I'm analyzing just the trip up? VF is 0, right? It comes to a stop. Like briefly, and then it comes back down, but for the part of the trip that I'm analyzing, VF is 0. Let's find displacement here. I think all we're going to do for this one is say d is equal to VFT minus 1/2 a t squared. Is that right? Does that seem right? I think so. VF is 0, so 0 times time is 0, minus, gentlemen, minus 1/2 of neg 9.81 times my time of 3.125. Let's square that. Let's pull out the calculator and figure this out here. Let's say 0.5 times, sorry, made a mistake here. Should be negative 0.5 times negative 9.81 times 3.125 squared gives me 47.9. And that's right, we should round this to 3 digits because my time is 3 digits, so is my acceleration of gravity 3 digits. Final answer is 47.9 meters. Now, did anybody do this analyzing the trip down? Anybody get 47.9 analyzing the trip up? Yeah? Good. If you analyze the trip down, what should you get? Negative 47.9. Okay, but that still means the maximum height of the ball is 47.9, right? I'd accept, I mean, it should be a positive because it's a height, but if you said negative 47.9, I wouldn't take off any marks for that. That would be full value. Okay, let's take a look at question number 10 then, and then we'll take a bit of a break here. Number 10 says, jumping straight up, how long will a red kangaroo remain in the air if it jumps through a height of 3.0 meters? Given the height, you're probably going to analyze the trip up or the trip down, right? Probably one of the two. Like, what do you want to do? Up or, let's go down, since we analyzed the trip up the first time. So I'm going to make this one blue here. Let's say displacement. If we're analyzing the trip down, the displacement will be negative 3. If we were analyzing the trip up, the displacement would be positive 3. A is negative 9.81. We're looking for time. Is there anything else we have if we read between the lines here? Yep. VI would be good. If we're analyzing the trip up, VF would be 0. Analyzing the trip down, then VI would be 0. You guys know what I mean by VI, right? Initial velocity, what I start at. When I was in high school, I had a great physics teacher in high school. But I remember taking grade 11 physics and then grade 12 physics, and he used to use this term D0. It means initial position. But he called it D0. And he never explained that. So for a year and a half, I remember going through physics for a year and a half, him saying, and he would say D0. And I had no idea what he was saying. For a year and a half, I had no idea what he was saying, D0. Okay? So if I ever say something like that, like DI or whatever, or VI or whatever, and you're not sure what that means, like ask me. Or if you're afraid to ask me in front of everybody, just ask me some other time, okay? Because you don't want to go a year and a half wondering what something means like I did. Okay. What do you want to do? Oh, you know what I want to do? I think I want to say d is equal to VIT plus 1/2 AT squared, don't I? Is that good? Why isn't that good? Oh, you know what? Oh, I saw a couple of people was walking around think this, and I think that I was thinking the same thing actually when I was walking around. And one person just referred to it here just now. Can't use this because it requires a quadratic equation. It actually doesn't. If VI is 0, then this whole term disappears, right? So the equation becomes now d is equal to 1/2 AT squared, and t is only in one place now, right? So let's solve for t. Let's take the half a over by dividing. So we're going to say d over 1/2 a equals t squared, and then t will be equal to the square root of that. Okay, we're going to solve for this. We're going to find that we get a number that's not actually the right answer, but we'll deal with that in a second here. -3 divided by 1/2 of -9.81. What am I going to get first here? Yeah, I get the bottom first. So let's say 0.5 times -9.81. There's the bottom. Then let's say -3 divided by that. There's what's inside the square root. And then let's square root that. We get a time of 0.782 seconds. But that's not my answer. That's not right. Have I done anything wrong? Have I done anything wrong? No, I'm just not finished. What do I got to do, Josh? You get 0.78? Okay, well, you're just about there. Like, you knew what you were doing, you just didn't quite finish. That's okay. What's wrong? I got to multiply by 2. Right? This is the time that it takes for the ball to fall downwards, right? If I want the time that it takes to remain, I want to find out how long it remains in the air total, then I need the time up and down. I have to double that, right? So 0.782 times 2, what does that give me? I don't know, somewhere around 1.6? 1.56, which we should actually round this to 2 digits, right, because of that. So it should be 1.6 meters. Or 1.6 seconds, I should say. Good? Yep, question?